Okay, so that's great in theory, but the question is what happens in practice when you actually want to cope with real code? And the biggest problem in coping with real code is non-local variables. Global variables are a particular type of non-local variable. There's a famous paper in 1973 by Bill Wolfe and Mary Shaw, which was entitled Global Variable Considered Harmful. And what they argued was that non-local variables were a major contributing factor in programs that are difficult to understand. So the thing they observed is that whenever you have a global variable and you're referencing the global variable, you can't always see where it was defined, what its meaning was, etc. And it turns out that many years later, okay, I guess 35 years later, what's the story? Okay, it turns out they're still used extensively. And part of the reason for that is because they avoid parameter proliferation. Because if you're not going to have it global, you have to pass it as an argument. And then what happens is you get these functions with long argument lists, okay, which you may have anyway, but you got even more. And the problem is that that sometimes all those arguments are doing is pass through to another function call, which then passes through to another function call. And all those intermediate functions, they don't really care about that variable. Okay, it's only somewhere at the leaf of your computation that anybody cares about. So it turns out that that this is very popular, but it also turns out that this is a real problem for parallelizing because they induce data races. Whenever you have something where you've got some global variable, you may have something that looks pretty parallel, but there's some place where you've got some place that down at the leaves, these two things are accessing the same variable, and that becomes a problem because now you have a race. And now you look at it and you say, gee whiz, that's really difficult and expensive to try to rip out and figure out where those things are and how you're going to restructure the code to pass them as parameters or whatever. Okay, that's okay. We've got a solution for you. So here's an example of a very simple piece of code where we're summing up a bunch of values. So the key part here is that we have some value, some result that's going to hold the sum, and we're running through a loop. And what we're doing is for each element of some array, my array, we are adding the value after computing on it. We're adding the value into result, and then we're going to go and print the result is, whatever the value is and return. So basically, we have the array. They each have a value. We're going to call the compute function on it. We're going to sum all those things up. So you can imagine, gee, this looks like, why don't we do all that computing, especially if it's compute intensive, in parallel. Great idea. So let's put a Cilk 4 in here. Okay, great. Now we go we now have a race. Okay, the problem here is what? It's that all of these guys are operating in parallel, but they're all trying to update that one result value at the same time, and that's a race. So there is a way that you can do this. There are some systems that will provide locks, mutual exclusion locks. And so you declare the mutual exclusion lock, and then you grab the lock before you update, and then you release it. And what the lock does is it guarantees only one thread of control can hold the lock at a time. And that makes it so that whenever anybody's updating it. Now, this is a particularly bad way to do it because this one, you're holding the lock even while you're doing the computation in order to update it. So better here, if you were going to use locks, is to do the compute first, then grab the lock, and then store it in. So you have to do a little bit of restructuring to use the lock. Even so, the big problem here is that you have lock contention now. Since every one of these guys has to grab the lock, you've taken an array of, say, size n, and you've parallelized it, very nice, but now you're serializing the updates to this location, okay, result. And so, in the end, you probably have no speed up out of this at all. It probably even slows down because of the overhead of grabbing the locks. So, unfortunately, locking is often a poor way to solve these race problems because you end up with no parallelism. And in addition, the updates are now all going to be going in some funny order. And so you may end up with, if it weren't an addition but were some other operation, you may end up with things that don't actually give you exactly the same result as you would get in a serial execution.